All right, welcome everybody. We are going to take some time to reflect and talk about what we experienced during the second session, the Moving Beyond Cross Multiply and Divide. So Marcie and I are here to kind of facilitate the discussion, answer questions you might have. There's not really a formal presentation scheduled for this, but it's just more of let's just kind of talk about it. So you can certainly unmute and share some comments and questions if you want, or you can chat them out and we'll respond that way as well. But essentially, we're just going to kind of take some time and reflect. We've been talking about the why we do things in math today, rather than how we do it. So we're just going to take a chance to go back and think about what we learned during that second session, and ask and answer any questions and just chat. So we have a Jamboard setup that we're just going to reflect on, and I think Marcie's put that out in the chat. Yep, so that's there in the chat. I want to minimize my screen here for just a second. I'm going to go back to this one. So in the Jamboard, there are a variety of questions. If you haven't used a Jamboard before, your tools are on there. You can just post a sticky. There's a sticky note that you can just use. You can click on that, enter your sticky, change the color if you like, and then post that to the pages that answer these various questions. What surprised you about this session? What are some things that maybe confused you? What can you use in your classroom? What are you already using? Maybe you're doing some of these things already. What was your experience like in the breakout rooms? And finally, the last slide is kind of just a tally of where you're at right now. And if you drop a little sticky on the different strategies, where you are, if you're comfortable using these, if you're not so comfortable using these, if you want to leave another comment and another sticky, you can certainly do that. But just grab a green or pink sticky and move them and put them around. So we're going to give you Marcie, how much did we give you last week? Was that about, how many minutes was that?
It was 10 to 15 minutes, 10 to 12.
Was that about 10, 15 minutes or so? Yeah, just to give you time to think about each question, and drop a sticky down in there. Yeah. So
there's a good comment in the chat. Did you see that, Marcie?
Yeah. I was going to say, Erin, I know at least you could probably look at the back page and think about how any of those things you feel strongly about, like that you feel good about teaching, or that you might want more support with.
Okay. Sure.
Even missing the morning session, I think that you could probably do that page at least, and then you glean from what the others talked about. We'll talk about here as we proceed.
Right. Okay, thank you.
Yep.
All right, so we'll give you 10, 15 minutes, I suppose we can do that, and then we'll come back together and discuss.
This is a little bit smaller group, so you guys might be a little faster, but we'll see where you're at. So go ahead. All
right, so we've had a chance to kind of think about it. And sometimes I know for when I reflect, it's like, wait a minute, I need to really think about it. And before I write something down, I need processing time to think about, like, wait a minute, was there something that surprised me? Was there something that was confusing? And then you've already had that other session in between this one as well. So, so we have a few responses, some comments and questions as well. So yeah, let me go back to slide one here. Let's just quickly see what people have. If we find we need to, we can actually go back through some of the examples that Liz shared as well. So if there's questions about particular problems, we can go back and look at those as well. Maybe that'll spark some comment or a question that you might have as well. So how her language supported conceptual understanding from stage. Yeah, yep. I think that's important to be able to have to do that, is know what's coming next and know what words you're choosing now and how they will impact the next level. So if you're teaching level A, level B, knowing the words that you're choosing at that point, at that stage, how that will affect a student's understanding of a level C or level D standard. but there was I don't remember where I first heard it, but I've heard it several times, like, don't teach something that the next teacher will have to unteach, kind of thing. So being aware of that language, I think, is important.
Yeah, I put that on there, and I was going to say we were having a discussion in our breakout room about her use of the phrase of the size blah blah blah, and when we were doing the multiplying, and so she kept saying, like, you know, like 4 groups the size of 2/3, and so. And when we started doing the problem, our facilitator pointed out that we had all said 4 times 2/3 of an hour or something like that. We like truncated it because of course we understand what we need to do, and so then we like started unpacking that, and we were like, do we need to go to that level of depth? And then when we went back to the main session and she moved on to division, it was like immediately obvious to all of us, like, why that saying it that way meant that when we got to division, students would understand what they were supposed to do better conceptually. We didn't need it at the multiplication level, but because we were practicing using that language at the multiplication level, when we got to the division level, it's less confusing what math you need to do. And I was like,
I think that's like from Sharma, right? Like thinking about the conceptual to the abstract. So thinking that 2/3 of an hour, what does that mean? It means a 20-minute block, like that helps them to like move from the freak out of the fraction to thinking about an actual part of the hour that they can relate to. So yeah, I think that's really powerful. You're right.
Anything else? Anybody want to comment? Those that posted, anybody else want to comment on their postings?
I need a little cheat sheet about like how to phrase stuff so that I don't have, you know, don't set it up so Marcie has to unteach it when they get to the next level.
Yeah. Yeah.
I think it's inevitable. I mean, we're all teaching conceptually the way we were never taught conceptually. So we're not, I like to avoid the like undo the teaching, but just acknowledge what they know and validate that, and then help them springboard to another concept. You know what I mean?
Yeah.
Like,
Yeah.
So.
Yeah. Yeah. I think what for me, what was the reference was like, if the previous teacher taught only cross multiply and that's all the student knows, now you've got to essentially unteach that to help the student get to the more complex, help them solve the more complex questions. So, but yeah, looks like folks didn't wasn't so much confusing. It's like more just like clearing up. Like let's see. Need to think. I just need more time to think about the jump from the double number line and tape diagram to the graph. Yeah.
I think that's valid. I think that's making sense of the problem, right? We all have to make sense of the problems ourselves. And then we have to teach the students how to make sense of the problems, because once we get it, then it's solid for us to be able to get them to be able to do that practice as well, making sense of it. So lots of initial prep just to wrap our heads around the concept.
Right. For me, it's like this continual journey of like, I want to just understand it more. I mean, I know how to get the answer to the question, but I want to understand more about it. And by, sometimes that's from a student asking me a question and going, I don't get it, or this is how I did it, and forcing me to reflect on why I do it the way that I do it. And I sometimes have said that I learn more math from my students than I ever did from my teachers, just because I've been forced to try to understand it and then explain it to my students, versus when my teachers taught it to me, it was just like, here's the rule, now practice the rule kind of thing. So being able to have this conceptual understanding of like, how do I jump from one type of diagram to another? Yeah, I think it takes time and effort on your part to kind of just go, okay, I need to what are the connections between these two things?
Yeah, she just had to move so quickly, and I felt like I, of course, understand how it goes onto the graph and like what are the pieces in between from working with these double number lines from these tape diagrams that I have to build in there in between so that students see how they go together, and we just like didn't have time to like really unpack that part of it.
Yeah, let's see. All right, looks like some folks have got some ideas here for what they're using. I don't know if I've heard that decimal section. You'll have to check that one out. Double number lines, yeah. I don't use them enough. I think that's something that I need to. I really like them, but I don't use them enough. Anybody else want to comment on there?
Tom, I was going to say, whoever wrote about the chocolate activity, do they want to talk about it?
Yeah.
It's me, you guys. I just keep talking. You told me I had to. So it's a little bit like the Dan Myers lemonade thing, but it's chocolate milk. And then there's a double number line that students are like sliding. No, students are putting into a table how many cups or spoonfuls. Oh man, I can't remember off the top of my head of the milk and the chocolate syrup that you need. Because Nana's mad, you made it wrong. And then it like puts it on the number line, and you can see like when the line is straight up and down, you've got an equivalent fraction. Your ratio is correct. And then if it's not, it's going to be this like weird slanted line because you've got more of one ingredient than you have of the other ingredient. It's not in the right proportions with each other. I think probably it could use, it's like a good like introduction to using the double number line. Like today she showed us, you know, doing it scaffolded where you provide the number line, which is kind of what the Desmos activity is doing. But then obviously we want students to be able to like use that strategy and apply it on their own. It doesn't give them an opportunity to make their own number line. So you would want to obviously like build more afterwards, but. And I used it with English language learners, like pretty low level last year, because it's so visual, they can see what they need to do, you know?
Yeah, it's definitely something that sounds like I have to check that activity out. Because Desmos has got a whole bunch of stuff. Yeah. Let's see. All right. What are people already doing in their rooms? I like the idea of connecting proportional stuff to your science, because that's and I think Liz mentioned that too. But I think she said her husband is a chemistry teacher, and of course when you're calculating chemical formulas and mixes, it's all proportional. I think even balancing chemical equations there's proportional thinking that goes on in there.
Yeah, proportions are just all over GED science. Like we just did weight equals mass times gravitational force. You've got like stuff with energy and in physics, balancing chemical equations, like you said, like it's just everywhere.
Right. Who posted about pixel art? Who posted that one?
That's me.
Can you, yeah. What it
So for I'm in the MAT program at Hamlin. For our theory and practice class, we had to do a lesson plan and a presentation. So I wanted to do something interesting for students to do this conversion from fractions to decimals to percentages. And so I Googled interesting things with that, and I found this art presentation that somebody else had done using colored cutout squares on a grid. And I didn't want to mess around with cutting out squares. And plus I've been teaching virtually. So I found pixel art, and it lets you select the size of the grid that you want to use, I think the default is 100 by 100, but you can expand your grid to 10 by 10, or even make it more difficult, like have your students choose 8 by 8. And then I have them take a screenshot and embed it in my Google worksheet. So then they can, count the number for the, they choose 2 to 5 colors, depending upon how much work they want to do from their artwork. And they can figure out what percentage of color is used. And then we can relate this back to like, my students really love to know about different careers that math is used in. So I would say, okay, if you're a graphic designer, you want to know how much ink to buy to print your design. So you would use something like this to figure out the percentage of red. And then I would show some, expanded calculations about that too. So that's what pixel art is all about.
Cool. I haven't heard of that one.
It's really fun.
It sounds interesting. We've been doing using the area model for decimals, multiplying decimals on the 10 by 10 grid. And that really messed with them.
Yeah.
It really messed with them at first to see it, but I can see how nice once they get identifying the decimal to be able to move that to percentages. And then, like you said, you put it in your Google form. So then you could redraw the lines to show the equivalent fractions that represent that same amount. That would be a good visual.
Right. Because it's like, well, especially with your 100 space grid,
Mhm.
squares out of 100 are red. Oh, it's 0.10, that's 10%. So, yeah, it kind of gives them the practical based on that. And then, also, they'll have a classmate that'll do the 64 and say, oh, 8 out of my 64 are red. And, that's also 10%. And it's like, well, how 8 64ths is the same as 10 100ths? How could that be? So it's pretty cool.
Cool.
The thing I do, that's my blue sticky there too, is I write out mathematics, especially word problems, really in script. And I like describing mathematics as a language to my students. And then we look for keywords. And then what are the symbols that you would use with that keyword? So I often keep at the top of the whiteboard, I'll keep a running vocabulary list, which is really handy for all my students, but my ESL or post ESL students in particular. And then, the symbols written after it. So that's kind of something else I do that's sort of like this, but not, quite the same as the number line, which I want to do too.
Yeah, that's a great idea. I try to do something similar to that. Like, I look at math, and math is a language to me. And so I think maybe that's, and so I kind of approach it from that. It's like here, so when you're looking at like a story problem, what parts of the story problem where's the operation, where's the thing that we have to do, or translating essentially from English
Right.
into mathematics.
Yeah, I use the word decode all the time. It's
Yeah.
like, how do we decode this? And, translation is a good word, vocabulary word I use as well.
Right.
But how do we decode? And then the GED is so word problem intense.
Right.
That, yeah, especially for my ELL students, we're talking about what's a time card, language that they're not getting in literacy classes, specifically kind of GED problem and occupationally related. There's kind of this heavy emphasis on occupations also in the GED word problems. So good too.
But I think there's a lot of power in making connections of all kinds, and we kind of talked about this in our last group, was the whole language development, not just with new like abstract English words, but also the math words language that all students don't have access to, and allowing them to make those connections. Like the reasons why these skills were named this word is because they mean this, that the language actually identifies or defines the skill kind of within it, and that makes a stronger connection. I think it reduces fear, it reduces intimidation of any kind, or overwhelmed when you're trying to figure out all those problems. So I think any kind of connections like that really builds strong student learning. So I think that's a good
Right.
plan.
Yeah, like we use these words like numerator and denominator, but how many of us actually know what the definitions of those words are and why we use those words to describe the top number and bottom number of the fraction? Very rarely are they used in general language outside of mathematics, but understanding words like that and definitions and where they came from, and can help with the understanding of, oh, numerator means it's a counting number, and denominator is a measurement size kind of thing, or it's a way of grouping things. And so, yeah.
Exactly. It really gets that rigor.
Mhm.
The deeper.
I mean, it helps me understand the concepts. If I know the meaning of, like, why do we even use this word? If I can understand the meaning of that word, I'm like, oh, okay, it means this, and now I can connect that to the concept itself, and it just helps clear up things for me.
Exactly.
I mean, we've heard for years from math teachers, even at the college, I've heard them say, I don't make them say those ridiculous words, or we can just focus on what the words mean. Like denominator means denomination, means unit, means, the size piece. Like we always sidestep teaching deeper understanding for the shortcut.
Right. Yeah, I'm going to move on to see what the breakout room. Any just a couple comments about the breakout room. My first breakout room was a little quiet. I think people were just kind of focused on looking at the questions, but I think it went too fast too. Also, I think we didn't have enough time. But yeah, it's like could have used more time. So part of the learning experience, I think, is just like, how do we use breakout rooms? If you've used them with your students, maybe you've probably come across a few bumps in the road here and there. I particularly haven't used them with my students. I've kind of kept things in a whole group, but I'm going to move along here to the next one, to our last slide. Essentially here as our last slide, just kind of summing up where people feel that they're at. So green is representing that you feel comfortable using that representation, and pink is you're not comfortable. And so someone posted that they're getting more comfortable, which is great. Growth mindset, we want that. So it looks like in this group we've got some folks that are fairly comfortable with most of these. So does anybody want to comment, ask a question?
I think it kind of, for me, goes back to my question from earlier. It's kind of like, I feel most comfortable using a particular model for a particular problem. And probably that mostly has to do with my previous experience with it, and sort of moving between them and bringing students along with me is the place where I feel like I could use more work. And part of that can be when we make it possible for students to solve problems flexibly, maybe they're going to use several different of these models, and then we can compare them and talk about it. But also sometimes students haven't used a model like this before, so we have to sort of teach them how to do that before they can move between them, and that piece is where I want to learn more.
Yeah, sometimes I'll choose a particular model just because I try to be intentional about the representations I use, depending on the question the student's asking. If they are working on a percent problem, I haven't used the double number line in the past, but after today, I'm more tempted to say that's going to be my go-to when I'm working on a percent problem with a student. But and ratio tables and graphs, if someone's working on algebra, that tends to be my go-to for that. But tape diagrams, that one I mean I'm comfortable with it, but I haven't really incorporated it in any way. It's not something I use. It's not usually a go-to for me. It probably should be.
it was so great to see today where she did the double number lines, she did a ratio table, she laid the ratio table on its side. Holy crap, that's a tape diagram. You know, like I think, well, maybe I just answered my own question. Like that's part of how we can show students the connections between them, right? But it just is a matter of
Doing it.
yeah,
Right.
yes. Yeah, exactly.
Yeah, I actually like kind of handpick some when I first introduced the lesson. And I keep that same idea over and over and over with those problems. And I force them to kind of try them out until they're comfortable with it if I'm building the concept. Because I have a lot of students who don't want to do the visual representation. They just already know the cross multiply divide thing. And it's actually painful for them to have to do the conceptual understanding. So I just acknowledge that they know that. I acknowledge that it works, but then I force them to conceptually build on the knowledge that they know. And like I said, I kind of handpick them the problems for a while just to keep it kind of successful for them to actually build the concept. And then I will move to the next, like tying it into the next, another way of looking at it. Or like, I don't jump all the time to the graphs. I will start with just those tape diagrams or the ratio tables for a long time when I'm building that. And then I will move it to the graphs. Another way to look at it is, but one conversation we had in the other group was that a lot of our GED students might come in and they want to move so fast. And they're like, we already know the method. Let's move on to the next thing. And so that kind of forces us to really think about how we want to develop our time with these students and what we want them to accomplish. If they do know how to solve it, then what does that look like to build the conceptual understanding? What do they need it for? And give it and kind of allow them to have some buy-in as to why they need it. And that's also tricky, I think.
Absolutely. I was just thinking, like, we are math instructors and we spent all morning making tape diagrams and bar models and stuff to better understand how we're going to instruct students. And it always deepens my understanding of the connections between them when we do that. But it is a matter of like building that trust and rapport with students. Like, I promise I'm taking you somewhere and it's going to be better. You'll understand more. You'll understand the connections. Just stay with me on the ride until we get there.
Right.
We were doing, they appear on Facebook all the time that like, what do you do when you see 27 and plus 48 or whatever? Explain your process. And one of the students, like right out the gate, she just did the standard algorithm, even though I said, do it in your head, you know, but then somebody else did it with the expanded notation, which we've been working on. And then like, I showed them how what they did was the same thing. And they were both like, oh, you know, and so like getting to those connections between them, I do think students then are like, okay, I'll try the other way. You're taking me somewhere.
But it's also intimidating. People don't like a new method.
Yeah.
Like I argue with my students the same as I argue with my brother. My brother's trying to help his child on their homework and they're doing partial products instead of the algorithm that he knows, and he's livid about the whole thing. And that's kind of how sometimes my students get, is they're like, well, I already know how to do this. Like, I don't want to know a new way. I don't want to apply my thought somewhere else. And you're right. You have to give them you have to help them see the connections. You have to help them understand that there is multiple ways of looking at it. And they might even like the other way. Like Tom said, I like the double line graph now for percentages or something like that.
Right. Yeah, it's part of, I think Chris, I think it's what did you say about building that rapport with your students so they trust you. So that, and they say, okay, yeah, my teacher's showing me this, they're going to help me get to the answer. It's, show me how to, and so they just trust that you know what you're doing. And so I think that's a huge part of it. But yeah, the hesitation or anxiety over something new and unfamiliar, I think that's just natural for all of us. But yeah, I mean, last year I was distance teaching, or just my kids were distance learning, and so they were here with me at home the whole time. And And I was watching my children learn their math assignments, and my oldest just struggles with connecting patterns. He's just finding those patterns in mathematics, and so I was giving him different ways to kind of like, here, look at this way. How about if you look at it this way? And thankfully, his teacher also is very into that, like multiple representations. And so she and I are kind of on the same page as far as the way we would approach math teaching. So that was great to see that a teacher like that. But yeah, sometimes just finding that and going, here, does this work for you better than this way? And so he ended up choosing ways, and that not necessarily standard algorithms.
Yeah, and I think to Marcie's point earlier is sometimes we gotta sort of like strong arm students to try the other ways, because then they have the choice of the way they prefer and the way they understand it best. But if they don't ever try the other way, then they don't get to choose what works best for them, because they only have that one way. And if you mess it up, you're sunk.
Do any of you like when you're having a class discussion, put the different students' representations on the board and then kind of just talk about the differences of them, to show everybody, so that everybody can see everybody's representation, including maybe your own, and kind of just compare. And so here's how so-and-so did it. Here's how so-and-so did it. Here's how I was taught how to do it, but this makes more sense to me. I've tried that a few times, and you get your students' eyes just open up, like, whoa, okay, they get the same answer, but in a different way. And sometimes they like a different method than the one they were taught.
And helping them see the connection between them just makes understanding go even deeper, you know? Yeah.
PEMDAS stands out for me with something like that. It's like, well, I did it this way. I did it this way. Well, here's why it works. And you know, that expanded notation you're talking about, is like, you know, why does that work?
I also pull out different test questions or book questions that show finding the expression as the answer instead of just finding the answer. That they can see that, oh, well, all of these choices are in proper form, or all of these choices are like partially solved, or that it isn't just a easy solve it the way they always solve it kind of thing, that they actually have to think about another way that could be correct, not just theirs.
Yeah. Are we coming? Are we done at 3, or are we getting a little bit of time past 3? I think
We're done.
We are done at 3.
If you
we're done at 3.
believe it.
We're down to just a few seconds left, everyone.
Well, we aren't going to kick you out or anything, but yeah.
No, but I want to respect people's time commitments too. So, yeah. So, well, thank you for joining us. Thank you for your contributions.
Yeah, thank you to Tom and Marcie for facilitating, and Rebecca for your help behind the scenes. We've got applause from Chris. Thank you. If people can find their reactions, you can totally applaud us. I'll stop the recording, but you're welcome to hang out for a sec.